200 billion stars fill our galaxy. Many of them are billions of years older than our Sun. 8 billion years passed before Earth even existed. That is 8 billion years where life could have emerged somewhere else, evolved, built ships, crossed the void. Even traveling at a fraction of light speed, a single civilization could colonize the entire Milky Way in just a few million years. The math is clear. The galaxy should be crowded by now. Signals everywhere. Probes drifting between stars. Megastructures large enough to dim distant suns. What if the silence we hear is not emptiness, but an answer? For 70 years, humanity has been listening. Radio telescopes, space probes, careful searches across thousands of star systems. We have found nothing. No transmissions, no visitors, no evidence that anyone else has ever looked up at the night sky and wondered the same thing we wonder. This is the Fermi paradox, the contradiction between what should be and what is. The universe insists it should be full of life. The evidence insists it is not. One of these must be wrong. 30 of the strangest and most unsettling theories ever proposed attempt to explain this silence. Some offer hope. Some suggest we are impossibly lucky. Others warn that the answer may be far darker than we are prepared to accept. If you enjoy what comes next, consider hitting that like button and subscribing. We begin now, and it began with a newspaper cartoon. Summer of 1950. Los Alamos, New Mexico. The same laboratory where scientists had split the atom just 5 years earlier. A group of physicists walked to lunch together, passing jokes back and forth about a recent string of flying saucer reports in the press. Someone had drawn a cartoon blaming missing trash cans on little green men. The whole thing was ridiculous. Everyone was laughing. Enrico Fermi walked with them, Nobel laureate, one of the architects of the atomic bomb, a man whose mathematical intuition was so legendary that colleagues called his back-of-envelope calculations Fermi estimates. He had a gift for cutting through noise to find the signal underneath. The group sat down in the cafeteria. The conversation drifted. Flying saucers became faster than light travel. Faster than light travel became interstellar distances. As the usual lunchtime speculation among people who spent their days thinking about the impossible. Then, Fermi stopped. He looked up from his meal and asked a simple question. 4 words. "Where is everybody?" His colleagues did not ask what he meant. They did not need clarification. They understood instantly. Given everything they knew about the cosmos, given the age of the galaxy, given the mathematics of probability, and given even the most conservative estimates about how life might spread through space, where were the visitors? Where were the signals? Where was the evidence that anyone else existed at all? The table went quiet. The silence. When we point our instruments at the sky and listen, we hear nothing. Just static. Just the hum of distant stars and the whisper of cosmic background radiation. No voices, no patterns, no messages. The silence is not an absence of data. It is the data. And it tells us something is wrong with our assumptions. Here is what makes this moment so strange. Fermi was not delivering a lecture. He was not presenting a carefully constructed argument. He asked his question almost casually, an offhand remark between bites of food. The most haunting question in the history of science began as a throwaway comment during a conversation about flying saucers in the newspaper. He did some quick calculations right there at the table, rough numbers, and nothing formal. And within minutes, he had sketched out a problem that no one has been able to solve in the 7 decades since. Consider what his question actually implies. Picture building a house. You measure every board. You cut every angle precisely. You drive every nail exactly where it should go. The foundation is level. The walls are square. The roof sits perfectly. Every measurement is correct. Every piece fits. And yet, when you step back and look at the finished structure, something is deeply, fundamentally wrong. The house should not be standing, but it is. Or, in the case of the universe, the house should be full of guests, but the rooms are empty. That is the paradox. Not a puzzle with missing pieces, a puzzle where the pieces we have should not fit together at all, yet somehow they do. The math tells us intelligent life should have emerged elsewhere long before Earth even formed. And the math tells us those civilizations had enough time to spread across every corner of the galaxy. The math tells us we should see their artifacts, their energy signatures, their transmissions. The math is clear. The observation says otherwise. Every telescope we have aimed at the sky has returned the same answer. Every signal we have sent has disappeared into the void without reply. Every probe we have launched has found only rock and ice and radiation. We have looked, we have listened, and we have waited, and the universe has given us nothing. The question Fermi asked at that lunch table is still hanging in the air, unanswered, untouched. The silence since that day has only grown louder. Every new instrument we build, every new frequency we scan, every new star system we examine, they all confirm the same uncomfortable truth. We cannot find anyone else. We cannot prove they exist, and we cannot explain why they do not. Fermi himself never published anything about his lunchtime question. He moved on to other problems, other calculations. He died 4 years later, never knowing that his casual remark would become one of the defining mysteries of modern science. But others took notice. A decade after that lunch in Los Alamos, an astronomer in West Virginia decided to do something Fermi had only sketched. He wanted to take the question seriously, to give it structure, to turn 4 words into mathematics, and he picked up a piece of chalk and wrote an equation. That equation is still there, not on the same chalkboard, but in every textbook, every lecture hall, every conversation about whether we are alone. It became the most famous formula in the search for extraterrestrial life, and the man who wrote it never intended for it to give us an answer. 1961, 11 years after Fermi's question hung in the air over that lunch table, an astronomer named Frank Drake invited 10 scientists to a remote radio telescope facility in Greenbank, West Virginia. They were there to discuss something no scientific body had ever formally addressed: the possibility of detecting intelligent life beyond Earth. Drake needed a way to organize the conversation. He needed an agenda. So the night before the meeting, he sat down and asked himself a simple question. What do we need to know to figure out how many civilizations might exist in our galaxy right now? He wrote 7 variables, multiplied them together, and created something that would outlast him. The Drake equation looks elegant, deceptively simple. You start with the rate at which new stars form in our galaxy each year. Then you multiply by the fraction of those stars that have planets. Then the fraction of those planets that could theoretically support life. And then the fraction where life actually appears. Then the fraction where that life becomes intelligent. Then the fraction that develops technology capable of sending signals into space. And finally, you multiply by how long such a civilization survives. 7 numbers, 7 multiplications, 1 answer that tells you how many communicating civilizations should exist right now. The problem is that we only know the first 2 numbers with any confidence. The rest are guesses. We are guessing whether life emerges easily or rarely. We are guessing whether intelligence is a cosmic inevitability or a freak accident. We are guessing how long civilizations last before they destroy themselves or go silent. We don't really know what to put in most of these variables. That's the honest answer. We're guessing. Educated guessing, but guessing. The equation is not a calculator. It's a confession of ignorance. Here is where it gets strange. Plug in optimistic numbers for each variable. Assume life is common. Assume intelligence follows naturally. Assume civilizations tend to survive for millions of years. Run the multiplication. You get millions of civilizations scattered across the galaxy. Millions of signals we should be detecting. Millions of neighbors. Now, plug in pessimistic numbers. Assume life is vanishingly rare. Assume intelligence almost never emerges. Assume civilizations burn out quickly. Run the same multiplication, yet you get one. Just 1 civilization in the entire galaxy. Us. The same equation, the same structure, wildly different conclusions, and we cannot tell which set of assumptions is closer to the truth. Those unknowns are like cracks in a dam. Small changes in any one of them can flood the entire calculation. Change one variable by a factor of 10 and your crowded galaxy becomes a graveyard. And change it the other way and the galaxy becomes a city so full that we should be tripping over alien signals every time we point a telescope at the sky. The equation does not solve the paradox. It organizes our ignorance, giving it a shape we can stare at. Drake himself understood this. He never claimed his equation would produce a reliable number. He created it as a tool for conversation, a framework for identifying exactly which questions we needed to answer, and which mysteries we needed to solve before we could say anything meaningful about life in the cosmos. The 10 scientists who gathered at Green Bank that autumn spent 3 days working through each variable. They debated. They disagreed. They left with more questions than they arrived with, and that was precisely the point. The equation was never meant to be solved. It was meant to reveal the depth of what we do not know. Consider the last variable. Last. How long does a technological civilization survive? We have exactly one data point. Us. And we have possessed radio technology for roughly a century. We have no idea if that number will be 200 years or 2 million. We cannot even predict our own future, let alone the lifespan of species we have never met on worlds we have never seen. That single variable can swing the entire calculation from hopeful to hopeless. This is what makes the Drake equation both powerful and frustrating. Yet it gives us a way to think about the problem. It breaks an overwhelming question into smaller, more manageable pieces. But it also shows us exactly how many of those pieces are missing. We are trying to solve a puzzle where most of the information has not yet arrived. The equation became famous not because it answered anything. It became famous because it elegantly displayed the shape of our blindness. Every term in that formula represents a frontier we have barely explored. Every multiplication sign connects one mystery to another. Drake lived to see his equation taught in classrooms around the world. He watched as new telescopes and new discoveries slowly filled in some of the blanks. The fraction of stars with planets turned out to be higher than anyone expected. That was encouraging, but the deeper variables remained stubbornly unknown. We still cannot say whether life emerges easily when conditions are right. Yet we still cannot say whether intelligence is a likely outcome of evolution. We still cannot say whether civilizations tend to destroy themselves or transcend their origins. The equation sits there, patient, waiting for us to fill in what we do not know. Perhaps the answer will come from better instruments, from telescopes that can analyze the atmospheres of distant worlds, from probes that can sample the oceans of frozen moons, from signals we have not yet learned to recognize. Or perhaps the answer will come from examining what we already know more carefully, from looking at the physical universe around us, the chemistry, the timescales, the conditions that make a world hospitable or hostile. The Drake equation tells us where to look. It does not tell us what we will find. And somewhere in that gap between mathematics and observation lies the truth about whether we are alone. The equation tells us where to look, but it does not tell us when to look. And that question changes everything. Our galaxy is ancient, 13 billion years old. That number is so vast it becomes meaningless without something to hold it against. Imagine the entire history of the galaxy compressed into a single calendar year. January 1st marks the moment the Milky Way began to form. Swirling gas, collapsing dust, the first stars igniting in the darkness. On that calendar, Earth does not appear until August, the middle of summer. For the first 7 months, our planet simply did not exist. No Earth, no moon, no oceans, nothing that would become us. 8 billion years passed before our world was born. Think about what that means. Let that settle. 8 billion years. That is not a gap. That is an abyss. During those 8 billion years, stars formed and died. Heavy elements forged in stellar furnaces scattered across the cosmos. Planets coalesced around countless suns. Water pooled. Chemistry happened. And we have no idea what else might have happened. Human civilization spans roughly 10,000 years. We carved our first cities from the wilderness about 400 generations ago. That is how long it takes to go from scattered tribes to global networks, from stone tools to satellites, from campfires to nuclear reactors. 10,000 years. Compare that to 8 billion. If you stacked our entire civilization end to end, you could fit it into that gap 800,000 times. Every empire that ever rose, every war that ever ended, every discovery that ever changed the world, stack them all together, then do it again and again, 800,000 times. That is what 8 billion years contains. The galaxy had time for civilizations to emerge on worlds we have never seen, time for them to build technologies we cannot imagine, time for them to spread across the stars, time for them to die, time for new civilizations to rise in their place, time for those civilizations to die as well. The cosmic stage was set for performance after performance, and we arrived only for the final act. Or perhaps not even that. Perhaps we arrived during intermission, and the next act has not yet begun. Consider what even a small head start would mean. A civilization that emerged just 1% earlier than us in the galaxy's history would have begun 130 million years ago. 130 million years. When that civilization was taking its first steps toward the stars, dinosaurs still ruled our planet. The asteroid that ended their reign had not yet fallen. Mammals were small, skittering creatures hiding in the shadows. Between that moment and this one, our entire evolutionary journey unfolded, from tiny mammals to apes, from apes to early humans, from early humans to us. Everything we have ever been, everything we have ever done, that is what 130 million years contains. And that is only a 1% head start. Consider humanity's journey from riding horses to landing rockets on the moon. That transformation took only a few centuries. 300 years separated the first telescopes from the first footprints on lunar soil. 300 years to go from squinting at the sky to walking on another world. Stretch that across 130 million years. The result is something that breaks the imagination. It shatters every framework we have for understanding progress. A civilization with that kind of head start would be to us what we are to bacteria. They would not simply be more advanced. They would be incomprehensible. Their technology would look like magic. Their capabilities would have no analog in our experience. They would have had time to make mistakes, catastrophic mistakes, civilization-ending mistakes, and then rebuild. And they could have destroyed themselves and started over 1,000 times. They could have colonized worlds, abandoned them, colonized different worlds, abandoned those too. They could have gone through cycles of expansion and collapse that make our entire history look like a single heartbeat. They could have filled the galaxy with their presence. And this is not speculation. This is mathematics. The Milky Way stretches 100,000 light years across. That sounds impossibly large. And it is large. But time is patient. A civilization does not need faster than light travel to reach every corner of the galaxy. They just need persistence. A spacecraft traveling at 1% of the speed of light covers enormous distances over millions of years. At that pace, a probe launched from one side of the galaxy could reach the other side in 10 million years. That is a long journey by human standards. It is nothing by cosmic standards. The galaxy had 8 billion years before we arrived. A colonization effort that takes 10 million years could have happened 800 times over. Not just once. 800 times. Wave after wave of expansion. Generation after generation of probes. Star after star claimed and catalogued. Even if a civilization moved slowly, even if they paused for millennia between each new world, even if they took detours, even if they made mistakes, they would still have filled the galaxy long before our sun ignited. This is the terror of the head start. Time is the one thing the universe has in abundance. If anyone started before us, they have had more than enough. The excuse that they simply have not had time to reach us falls apart under the weight of these numbers. 8 billion years is not a waiting period. It is an eternity. The galaxy should be crowded. It should be teeming with the evidence of ancient travelers. And their probes should have visited every star. Their signals should wash over us like rain. Their footprints should be everywhere we look. They have had time to colonize, time to get bored, time to abandon everything, time to start again. They could have done it all over again before our sun even ignited. And yet, we look up at the night sky and see nothing. No signals, no probes, no structures, no signs that anyone has ever been anywhere. The emptiness is total. The quiet is absolute. If time is not the barrier, what is? If time is not the barrier, then maybe the barrier is something else entirely. Maybe it is evidence. Maybe it is the simple, maddening requirement that real proof has to show up more than once. On August 15th, 1977, an astronomer named Jerry Ehman sat down to review data from the Big Ear radio telescope at Ohio State University. This was not glamorous work. The telescope scanned the sky automatically, printing out long columns of numbers and letters on fan-fold paper. Most of it was noise, static from the cosmos, the background hum of a universe going about its business. Ehman was looking through the printout, checking for anomalies, row after row of characters. Nothing unusual, nothing worth a second glance. And then he saw it, a vertical column of letters and numbers that did not belong, a signal that jumped off the page. He grabbed a red pen and circled the sequence. In the margin, yet he wrote a single word. Wow. That was all he could think to say. The signal had lasted exactly 72 seconds. That was not random. 72 seconds was precisely how long the Big Ear telescope would track any given point in the sky as the Earth rotated beneath it. Whatever made this signal, it was fixed in space. It was coming from out there, somewhere in the direction of the constellation Sagittarius. The frequency caught Ehman's attention most of all. The signal sat near 1420 MHz on the radio dial. That number matters. 1420 MHz is the frequency at which hydrogen atoms naturally emit radiation when they change their energy state. Scientists call it the hydrogen line. Hydrogen is the most common element in the universe. It drifts between stars. It fills the voids between galaxies. If you wanted to send a message across interstellar space, and if you wanted to pick a frequency that any intelligent species would recognize, you would choose the hydrogen line. Every astronomer on every world would know it. It is the universal channel, the cosmic calling card. And on that summer night in Ohio, something broadcast on that channel. Something strong, something brief, something that looked exactly like what scientists had been hoping to find since the search began. Ehman stared at the printout. His heart must have raced. This was it. Yea, this was the moment everyone had been waiting for. A voice calling out from the darkness, saying a single word, and then going silent forever. The team went back to that patch of sky. They pointed the Big Ear at the same coordinates, night after night. They listened. They waited. They prayed for a repeat. Nothing. The signal did not return. They tried again with more powerful equipment. Still nothing. Other observatories joined the search over the following years. Dishes around the world turned toward Sagittarius, straining to hear even a whisper of what had been so clear that August night. The silence swallowed it whole. 50 years have passed since Jerry Ehman wrote that word in the margin. Half a century of searching, half a century of hoping, half a century of returning to those same coordinates with better instruments, more sensitive receivers, and more desperate patience. The signal has never been detected again, not once. Imagine hearing your name whispered in an empty house. You freeze. Your breath catches in your throat. You wait, perfectly still, listening for hours. Nothing. Was it real? Was it your imagination? Did someone actually speak? Or did your mind create a sound from the creaking of old floorboards? You can never know. That question will follow you for the rest of your life. Did someone call out to me? That is what science has lived with for half a century, at a single syllable from the void that refuses to repeat itself. The cruelest aspect of the wow signal is not that we cannot explain what it was. We have theories. Some scientists suggest it was a terrestrial signal bouncing off space debris. Others point to passing comets releasing hydrogen clouds. A few believe it was exactly what it appeared to be. But explanations are not the problem. The problem is verification. Science does not work on single observations. It cannot. Yet the entire structure of scientific knowledge rests on one principle: repeatability. If you cannot reproduce a result, you cannot confirm it. If you cannot confirm it, you cannot build on it. A single data point, no matter how compelling, is scientifically indistinguishable from a fluke. It might be the discovery of the century. It might be nothing at all. Without repetition, there is no way to know. The universe showed us something extraordinary that night. Then, it refused to show it again. Yet that is not mystery. That is cruelty. Every few years, someone proposes a new explanation for the wow signal. Comet trails, satellite interference, equipment malfunction. None of these explanations have been proven either. They are just alternatives, ways to explain away the uncomfortable possibility that for 72 seconds, something out there tried to say hello. The coordinates still exist. The constellation Sagittarius still hangs in our sky. The Big Ear telescope is gone now, demolished in 1998 to make way for a golf course. But other telescopes carry on the work. They still listen to that patch of sky. They still hope. The silence stretches on. What makes this story so haunting is how perfectly it captures the entire paradox. We are searching for something that leaves no trace. We are listening for a voice that speaks once and never again. If the universe is full of civilizations, why do they behave like ghosts? Why one signal in 70 years of listening? Why nothing before or since? The wow signal is not just an unsolved mystery. It is a miniature version of everything we face, a glimpse of something that vanished before we could understand it, a door that opened for 72 seconds and then closed forever. Maybe signals like this happen all the time. Maybe they flicker across our instruments and disappear before anyone notices. Maybe the galaxy is full of one-time broadcasts that arrive, and go undetected, and fade into the static. We would never know. We cannot listen to the entire sky at once. We cannot monitor every frequency simultaneously. We catch fragments, pieces, hints that something might be out there. And when we finally catch one, when we finally hold something real in our hands, it slips away before we can prove it. The silence that has lasted 50 years since the wow signal is not just emptiness, it is a kind of answer. It tells us that even when evidence arrives, it may not stay long enough to matter. Even when the universe speaks, it may not speak twice. If evidence can vanish this completely, what barriers might exist that we have not yet imagined? If evidence can vanish that completely, maybe the problem is not what we are searching for. Maybe the problem is how we are searching. We talk about humanity's search for alien life as though it has been some grand, sustained effort, decades of listening, vast networks of radio telescopes pointed at the heavens, scientists combing through endless data streams, hunting for any hint of intelligence. The popular image is of a species casting its net wide across the galaxy, waiting for something to swim in. That image is wrong. The truth is far more humbling. We have not been searching the cosmos. We have been pecking at the edges of it with tools that barely work. Our ability to send and receive radio signals is new, staggeringly new. As a century ago, we could not have detected a transmission from another star system, even if one had arrived directly overhead. The technology simply did not exist. Radio broadcasting began in the early 1900s. Our species is perhaps 100 years old as a radio-capable civilization. In cosmic terms, we learned to speak yesterday. Every radio signal we have ever produced travels outward at the speed of light. Those signals form a bubble around Earth, and that bubble has been expanding for roughly a century. Right now, the edge of that bubble sits about 100 light years from here. That is how far our presence reaches. 100 light years in every direction. The Milky Way stretches 100,000 light years across. Picture a single candle in the center of a dark warehouse the size of a city. That candle is us. That tiny sphere of flickering light is everything we have ever broadcast. And the walls of the warehouse are lost in the darkness, completely untouched by our glow. If anyone out there is listening for us, they would need to be within that bubble to hear anything at all. Everything beyond it has no idea we exist. And even within that bubble, our signals grow weaker with distance. By the time they reach the far edge, they have faded into noise, a whisper dissolving into static. We have made one deliberate attempt to shout louder. In 1974, astronomers used the Arecibo telescope in Puerto Rico to transmit a message intentionally into space. 3 minutes of carefully coded information. Our number system, the structure of DNA, a rough map of our solar system, a stick figure of a human being. They aimed it at a cluster of stars called Messier 13. That cluster sits 25,000 light-years away. The message is still traveling. It will take another 25,000 years to arrive. If anyone receives it and replies immediately, the response will reach Earth 50,000 years from now, longer than our entire recorded history, longer than every kingdom, empire, and nation that has ever existed. That was our shout into the darkness, a single 3-minute broadcast aimed at one tiny point in the sky, sent once and never repeated. The rest of our search has been listening, and that listening has been far more limited than most people realize. A study conducted at Penn State in 2018 tried to calculate exactly how much of the searchable universe we have actually examined for signs of extraterrestrial intelligence. The researchers looked at every major search effort. They accounted for the frequencies monitored, the directions targeted, the sensitivity of the equipment used. Then, they compared the volume of space we have meaningfully searched to the total volume where signals could potentially originate. So the comparison they produced is devastating. Imagine the entire search space as the volume of Earth's oceans. Every drop of water on the planet, the Atlantic, the Pacific, the Indian Ocean, the deep trenches, the shallow seas, all of it. Our search so far amounts to roughly the volume of a hot tub. 70 years of effort, thousands of hours of telescope time, countless headlines about the search for alien life, and we have checked a hot tub's worth of ocean. But we have been asking, where is everybody while standing in a puddle, squinting at the horizon? Actually, let me put that differently. We have not been searching for 70 years. We have been trying to figure out how to search for 70 years. The real search, the one with tools that might actually work, is just beginning. For most of our listening, we have been using equipment designed for other purposes. Radio telescopes built to study pulsars and quasars and distant galaxies. They occasionally pointed at promising stars during spare observation time. We have been eavesdropping on the universe with borrowed equipment, catching scraps when nothing more important was scheduled. Our sensitivity has been crude. Our frequency coverage has been spotty, and we cannot listen to the whole sky at once. At any given moment, our telescopes are pointed at a tiny fraction of the visible heavens. The rest goes unmonitored. If a signal arrived from any other direction, then we would simply miss it. Imagine trying to hear a whisper from across an ocean while standing in a thunderstorm. That is our search. The wind howls, the waves crash, lightning cracks overhead, and somewhere out there, across thousands of miles of churning water, someone might be whispering. We strain to hear. We catch nothing, and we conclude that no one is speaking. But something is changing. The tools are getting better. In 2021, as we launched the James Webb Space Telescope, its mirror spans 21 feet across, the largest ever sent into space. This instrument does not listen for radio signals. It does something different. It watches starlight as it passes through the atmospheres of distant planets. By studying how that light changes, scientists can detect the chemical fingerprints of those atmospheres. This matters because life leaves traces: oxygen, methane, certain combinations of gases that should not exist together unless something is producing them. For the first time, we have a telescope capable of scanning distant worlds for the signatures of biology. Not intelligence, not technology, just life. The kind that breathes and metabolizes and changes its environment. The Habitable Worlds Observatory, planned for the late 2030s and into the 2040s, will take this further. Purpose-built to analyze exoplanet atmospheres, designed from the ground up to answer one question: is anyone else alive out there? The Fermi paradox might not be a paradox at all. It might just be impatience dressed up as philosophy. We have been frustrated by the silence. We have wondered why no one answers. We have constructed elaborate theories to explain the emptiness. But maybe the emptiness is an illusion born from inadequate tools. And maybe we have been staring into the darkness with eyes that could barely see. The galaxy is vast. Our reach is small. Our listening has been fragmented, intermittent, crude. We dipped a cup into the ocean, found no fish, and wondered if the sea was dead. The next generation of instruments will change the nature of the question. Not answer it, change it. For the first time, we will have genuine capability, real tools, a search that covers more than a hot tub's worth of space. And what comes next depends on what we find. Robin Hansen was not an astronomer. He was not a biologist. He did not study stars or cells or the chemistry of distant atmospheres. He studied economics, probability, the mathematics of decision-making under uncertainty. And when he looked at the Fermi paradox, he saw something that the astronomers and physicists had missed. He saw an accounting problem. The logic was simple, almost embarrassingly so. And the numbers say civilizations should be common. The evidence says they are not. Both of these things cannot be true at the same time, unless something is killing them. Hansen called it the Great Filter. Not a wall that civilizations hit and survive. A filter. Something that strains out almost everything that tries to pass through. A barrier so deadly, so improbable to overcome, that across billions of years and hundreds of billions of stars, almost nothing makes it to the other side. Picture a staircase. It stretches from dead rock to the stars. Each step represents a milestone in the journey from nothing to everything. The first step is chemistry, becoming biology. Simple molecules arranging themselves into something that can copy itself. The next step is those simple organisms becoming complex. Cells swallowing other cells and learning to cooperate. Then comes intelligence. Creatures that can think, plan, remember. Then technology. Tools that extend beyond the body. And then spaceflight. Then spreading across star systems. Then filling a galaxy. The Great Filter says that somewhere on that staircase, there is a step so hard, so deadly, so unlikely to be cleared that almost no one makes it through. We just do not know which step, and everything depends on the answer. This is what makes Hansen's idea so unsettling. It is not a theory about aliens. It is a theory about probability and extinction, an economic argument dressed in cosmic clothing. And he was calculating survival rates the same way an actuary calculates insurance risks, looking at the inputs, looking at the outputs, finding the gap that cannot be explained by chance alone. The filter does not care what form it takes. It could be chemistry. Maybe the jump from non-living matter to the first self-replicating molecule is so fantastically unlikely that it almost never happens. Earth might have won a lottery with odds of 1 in a trillion. If that is the case, yes, the galaxy is not filled with dead civilizations. It is filled with planets where life never started at all, sterile worlds, chemistry that never woke up. Or the filter could be cellular. For nearly 2 billion years, life on Earth was nothing but single-celled organisms drifting through ancient oceans. Then something happened. One cell engulfed another, and instead of digesting it, they merged, became partners. This event gave rise to complex cells with internal machinery. Without it, there would be no plants, no animals, no brains. Maybe that merger is the filter, a biological accident so improbable that it almost never occurs twice. The filter could be intelligence itself. Plenty of creatures have survived for hundreds of millions of years without developing anything like human thought. Sharks have been around for 400 million years. They have never built a radio telescope. Maybe intelligence is not the natural destination of evolution. And maybe it is a strange detour that almost never happens. Or maybe intelligence is common, but technology is not. Dolphins have complex communication. Crows use tools. Octopuses solve puzzles. None of them have developed writing or cities or rockets. Maybe the jump from clever animal to civilization-building species requires a combination of traits so rare that it almost never aligns. Any of these could be the filter. Any of them could explain the silence. But here is where Hansen's idea turns from puzzle to nightmare. The filter has a location. It sits somewhere on that staircase, and its position determines our fate. If the filter is behind us, we have already passed through. The hard part is over. The impossible step was something in our past. The formation of life itself, the development of complex cells, the emergence of intelligence, some hurdle that we cleared without even knowing how unlikely it was. In this version, yes, the galaxy is empty because we are among the first to make it this far. The silence is not a warning. It is simply early. We are pioneers standing at the edge of an empty frontier. But if the filter is ahead of us, the story changes completely. If the filter is ahead, then everything we have accomplished means nothing. Every civilization that has ever developed technology has reached a certain point and stopped, destroyed itself, hit some barrier that no amount of cleverness or cooperation can overcome. Nuclear annihilation, engineered pandemics, climate collapse, artificial intelligence that turns on its creators, something we have not even imagined yet. In this version, the galaxy is silent because civilizations die, all of them, always, right around the point where they start looking outward and wondering if they are alone. The two possibilities are not equally terrifying. They are terrifying in opposite directions. If the filter is behind us, we are extraordinarily rare, precious, the universe's unlikely champions. Every piece of bad news about the odds of life becomes good news about our survival. The harder it is to develop complex cells, the more likely we are the exception that already made it through. If the filter is ahead of us, we are doomed. Not probably doomed, certainly doomed. Yet because whatever destroyed every other civilization in the galaxy is waiting for us too. And we do not know what it is. We do not know when it comes. We only know that no one else has survived it. This is the binary that Hansen identified. Two doors. One leads to an empty galaxy where we might flourish. The other leads to a graveyard where we will soon take our place among the dead. The same silence. The same empty sky. But completely different meanings hiding behind identical observations. An economist looking at survival rates. That is how we arrived at the most important question our species might ever face. Not through telescopes or spacecraft or signals from distant stars. Through probability theory and the cold logic of accounting for the missing. The math demands an explanation. Something must be filtering civilizations out of existence. Something must be stopping the explosion of life that should have filled every corner of the galaxy by now. The filter is real, and it exists somewhere on the path from chemistry to cosmos. We need to understand both possibilities. We need to examine what it would mean if the filter is behind us, and we need to confront what it would mean if the hardest part still lies ahead. Let us start with the hopeful version. Hold on to it. 3.8 billion years ago, something happened on Earth that we still cannot explain. Chemistry became biology. Dead molecules started copying themselves. Life began. Yet we call this abiogenesis. The word means the origin of life from non-living matter. We know it happened. We have no idea how. Scientists have spent decades trying to recreate that moment in laboratories. They have mixed amino acids, sparked primitive atmospheres, pressurized volcanic vents. They have come close. They have never succeeded. Whatever bridge crossed the gap between chemistry and life remains invisible to us. We cannot find the recipe. We cannot repeat the experiment. We only know that Earth managed it once. If that transition is genuinely difficult, if the odds against it are astronomical, yet then here is your first candidate for a filter behind us. A filter so severe that most planets never cross it at all. But life starting was not the only hurdle. For the next 2 billion years, Earth was covered in single cells, simple organisms, bacteria floating in ancient seas, nothing more complex than a speck. 2 billion years. Try to feel that duration. Human civilization is 10,000 years old. Stack that civilization end to end 200,000 times. Now, that is how long life stayed simple. Then, something extraordinary occurred. One cell absorbed another. The absorbed cell did not die. It became a permanent part of its host, mitochondria, the power generators inside every complex cell in your body. This process is called endosymbiosis, two organisms becoming one. It happened exactly once in Earth's history, once in 2 billion years. Without that accident, life would have stayed microscopic forever. No animals, no plants, no eyes or brains or hands, just films of bacteria on wet rocks until the sun expanded and burned them away. If endosymbiosis is genuinely rare, if most planets spend their entire existence covered in nothing but microbial slime, then here is your second filter behind us. Another gate we passed through without understanding how unlikely it was. There is a third candidate, and this one involves violence on a planetary scale. 4.5 billion years ago, when Earth was still young, a world the size of Mars crashed into it. Astronomers call this object Theia. The collision was catastrophic. It liquefied both planets. It threw debris into orbit that eventually became our moon. But it may have done something else. Recent research suggests that the Theia impact created the conditions for plate tectonics, the slow churning of Earth's crust, the recycling of carbon, the thermostat that kept our planet habitable for billions of years. Venus has no plate tectonics. It baked into a furnace. Mars has no plate tectonics. It froze into a desert. Earth survived because another planet crashed into it at exactly the right angle, at exactly the right time, leaving behind exactly the right moon. If these filters are behind us, then we are not ordinary. We are the survivors of a gauntlet so brutal that virtually no one else made it through. The silence is not a warning. It is simply empty space waiting for pioneers. Hold that thought. Now, let go of it. And because if the filter is ahead of us, everything changes. Nuclear weapons emerged in 1945, the same decade humans first watched a mushroom cloud rise over a desert. We gave ourselves the ability to end our civilization in an afternoon. That capability has not disappeared. It has spread. It waits in silos and submarines across the planet. One miscalculation, one leader with nothing to lose, and the experiment ends. Climate collapse is not hypothetical. It is underway. Our oceans warming, ice sheets sliding toward the sea, feedback loops accelerating beyond our models. This is not a future threat. It is a present process. We are inside it. But here is the calculation that should disturb you most. In 2023, physicist Michael Garrett estimated the window between developing radio technology and developing potentially civilization-ending artificial intelligence. His number was roughly 200 years. 200 years. Yet we invented radio about a century ago. We are building artificial intelligence right now. If his estimate is correct, every technological civilization in the galaxy faces this same window, a brief span where their tools become smart enough to destroy them. 200 years is nothing. On cosmic scales, it is a heartbeat between first signal and final silence. This is the part that should stop you cold. We have spent decades hoping to find life elsewhere. Some researchers do not celebrate when they hear those hopes. They get nervous, because every piece of good news about alien life becomes a warning. Picture this: a future mission to Mars, robots drilling into ancient rock, and in the samples they return, something no one expected: fossilized bacteria, evidence of independent life, life that arose separately from Earth. Most people assume this would be wonderful news. It would be one of the most ominous discoveries in human history. And here is why. If life arose independently on Mars, it means abiogenesis is not that hard. The filter behind us, that impossible transition from chemistry to biology, turns out to be easy. Easy enough to happen twice in the same solar system. Easy enough that it probably happens all over the galaxy. And if the early filters are easy, then where is everyone? Finding microbial life on Mars would not be a celebration. It would be finding a lottery ticket that says you have already won the easy rounds. The hard one is next. Think about it. The more common life is in the universe, the more terrifying the silence becomes. If life is everywhere, if it spreads across billions of planets, then something is stopping it from reaching the stars. Something is killing civilizations before they can become visible, and that something is still ahead of us, waiting. Every discovery that makes the universe seem more hospitable makes our future seem more fragile. Every fossil, every organic molecule, every hint of biology on another world adds weight to the filter ahead. The silence is not evidence that we are alone. The silence is evidence that civilizations die, that emergence is easy and survival is impossible, that the staircase has no ceiling, only a missing step somewhere above us, a step that everyone falls through. That we have been treating the search for alien life as a treasure hunt. Find something and we win. Under the great filter theory, finding something means we lose. It means the easy parts are behind us, and the extinction event that no one survives is still coming. This is the razor edge we walk. Two possibilities that look identical from where we stand. Behind us or ahead, miracle or doom. The same empty sky, the same quiet frequencies. At the same unanswered question echoing since 1950. The filter exists. We know that much. The math demands it. The absence proves it. Something is removing civilizations from the galaxy faster than they can appear. The only uncertainty is where it sits on that long staircase from dead rock to living cosmos. Perhaps we have already passed through fire and did not realize it. Perhaps our grandchildren will face the fire themselves. We cannot know, yet we can only look at the evidence and weigh the possibilities. But there is another way to read the silence. What if civilizations are not dying at all? What if they simply never get the chance to be born in the first place? What if the problem is not survival, but existence? What if the universe is full of worlds that look promising, but cannot produce anything that thinks? The filter assumes civilizations rise and fall. But what if most planets never rise at all? And most planets never rise at all. That idea changes everything. The great filter assumes civilizations emerge and then fail. But what if the failure happens before the first spark of thought, before the first cell divides, before the conditions for life ever come together in the first place? In the year 2000, a paleontologist named Peter Ward and an astronomer named Donald Brownlee published a book that proposed something radical. They called it the rare Earth hypothesis. Yet their argument was simple and devastating. Earth is not a typical planet. Earth is a freak, a cosmic accident, a combination of factors so improbable that complex life might be vanishingly rare across the entire galaxy. Not because civilizations destroy themselves, but because the planets that could produce civilizations almost never form at all. Consider where we sit. Not just in our solar system, but in the galaxy itself. There is a narrow band called the galactic habitable zone, and too close to the galactic center, and you are bathed in radiation from supermassive black holes and packed too tightly with neighboring stars. Gravitational chaos, sterilizing bursts of energy, too far toward the outer rim, and the stars are metal poor. Heavier elements, the kind that form rocky planets, simply do not exist in sufficient quantities. Earth sits in a sweet spot, not too close, not too far, just right. But location is only the beginning. Our sun is a G-type star, stable and consistent. It has burned steadily for billions of years, giving life time to evolve without interruption. Most stars in the galaxy are not like this. Most are red dwarfs, smaller and dimmer, prone to violent flares that would strip atmospheres and irradiate surfaces. Planets orbiting red dwarfs have to huddle close to stay warm, so close that they become tidally locked, one side burning, the other freezing. Life on such worlds faces obstacles we can barely calculate. We dodged that fate by orbiting the right kind of star. Then there is Jupiter, that enormous gas giant out beyond Mars. For most of Earth's history, Jupiter has been a silent guardian. Its massive gravity acts as a shield, pulling in or deflecting asteroids and comets that would otherwise rain destruction on the inner planets. Without Jupiter, Earth would have been pummeled relentlessly. The frequency of extinction-level impacts would have been far higher. A complex life might never have had the long, stable stretches it needed to evolve. Jupiter did not have to be there. It did not have to be that size. It did not have to settle into that orbit. But it did. And then there is the Moon. Our near Moon is unusually large for a planet our size. It formed in violence, born from debris after a world-shattering collision. That collision did more than create a companion in our sky. The Moon stabilizes Earth's axial tilt. Without it, our planet would wobble wildly over millions of years. Seasons would become catastrophic. Ice ages would sweep across the tropics. Equatorial regions would freeze and thaw unpredictably. The stability that allowed life to adapt and diversify, the steady rhythms of seasons and climates, all of that depends on a collision that happened to occur in exactly the right way. Picture rolling a dozen dice. You need every single one to land on 6. One wrong roll, a slightly larger star, no Jupiter, and no moon-forming impact, and you get Mars, frozen, dead. A world that might have held liquid water once, but lost its atmosphere and became a cold desert. Or you get Venus, a pressure cooker hell with surface temperatures hot enough to melt lead. Both of those worlds probably started with similar raw materials. Both of them failed. Earth threaded the needle. Think about what that means. Let that settle. Recent research, studies published in 2024 and 2025, it has added another layer to this lottery. Scientists have linked that ancient collision, the one that formed the Moon, to something even more fundamental. Plate tectonics, the slow grinding of continental plates beneath our feet, the process that causes earthquakes and volcanoes. For most of history, we thought of plate tectonics as geology, as something that just happens on rocky worlds. It turns out that might be wrong. Most rocky planets appear to be geologically dead, yet their surfaces are static. Their interiors have cooled into stillness. Without active tectonics, carbon does not cycle. Volcanoes do not release gases. Rocks do not absorb carbon dioxide from the atmosphere. The delicate balance that keeps a planet from boiling or freezing, the thermostat that regulates climate over billions of years, simply does not function. Earth has that thermostat because of plate tectonics. And plate tectonics may have been triggered by that same violent impact that gave us our Moon. One event, one collision, and it set in motion the processes that would keep our world habitable for eons. Mars had no such luck. Venus had no such luck. Their crusts are frozen in place. Their climates spiraled out of control. One became a frozen tomb. The other became a furnace. The rare Earth hypothesis does not require civilizations to destroy themselves, and it does not require filters that wipe out species after they become intelligent. It simply observes that the conditions for complex life might be so rare, so dependent on chance, that the galaxy is filled with worlds that never had a chance to begin with. Sterile rocks, frozen wastelands, boiling atmospheres, planets that look promising from a distance but fail one of the dozen tests required for life to take hold and flourish. And maybe, in the entire galaxy, almost nothing else has passed all those tests. Maybe Earth is not one of billions of habitable worlds. Maybe Earth is one of a handful, or one of a dozen, or one. The silence of the cosmos might not be the silence of failed civilizations. It might be the silence of empty nurseries. Worlds where the conditions simply never aligned. Worlds where the dice never came up all sixes. This is a different kind of loneliness. Not the loneliness of survivors in a graveyard, yet the loneliness of the only child ever born. But the physical explanations only go so far. What comes next enters much darker territory. The darkness ahead is not empty, it is full. That is the theory. That is the nightmare. And it comes from a science fiction novel published in 2008. Liu Cixin called it The Dark Forest. The idea spread beyond fiction almost immediately, because the logic behind it is terrifying, and the logic is airtight. Or picture the galaxy as a vast dark forest at night. Every civilization is a hunter moving through the trees. You cannot see far. You cannot hear clearly. In that darkness, you have no way to tell friend from enemy. You cannot see their weapons. You cannot read their intentions. You cannot know what they want, what they fear, what they might do if they saw you first. If you call out, you reveal your position. If another hunter knows where you are, They have a choice. They can try to communicate. They can hope you are friendly. Or they can eliminate you before you become a threat, before you grow stronger, before you find them. The forest stays silent because every hunter who made noise is dead. This is not paranoia. This is game theory. Cold mathematics applied to the problem of survival across the stars. Consider two civilizations that discover each other. They are separated by dozens of light years, maybe hundreds. A message sent today will not arrive for decades. A response will take decades more. Real-time conversation is impossible. You cannot shake hands. You cannot look into their eyes. You cannot verify anything they tell you. They say they come in peace. Maybe they do. Maybe they are lying. Maybe they mean it now, but will change their minds in 1,000 years when their population grows and they need your resources. You have no way to know, and they face the same problem looking back at you. They cannot trust your promises either. They cannot verify your intentions. This is where the mathematics gets ugly. The cost of trusting the wrong civilization is extinction, not war, not occupation, complete annihilation, your planet sterilized, your species erased, every song, every story, every child who might have been born, gone. That is the penalty for guessing wrong. Under those conditions, the math allows only two rational strategies. First, stay completely silent. Never broadcast. Never reveal your existence. Hide in the darkness and hope no one ever finds you. Move through the forest without making a sound. Second, if you detect another civilization, strike first, before they can grow stronger, before they can threaten you, before they have a chance to make the same calculation you just made and point their weapons at your world. There is no third option. Cooperation requires trust. Trust requires communication. Communication requires time. And time is exactly what you do not have when the stakes are extinction. The mathematics creates chains of suspicion that stretch forever. Even if you genuinely want peace, you have to consider that the other civilization might be afraid of you. And if they are afraid, they might strike first out of fear. So you have to consider striking first to prevent their preemptive strike. But they know you might be thinking that, so they might strike even sooner. The chain keeps going. A fear builds on fear. Suspicion feeds suspicion. The only way to break the cycle is to remove the threat entirely, to strike before the other side even knows you exist. The forest is not silent because it is empty. The forest is silent because silence is survival. The silence is strategy. Now think about what humanity has done. In 1974, we aimed a radio telescope at a distant star cluster and broadcast a message. Here we are. Here is our solar system. Here is our DNA. And here is what we look like. We announced ourselves to anyone listening within range. The Voyager probes drift through interstellar space right now, each carrying a golden record. The records contain greetings in dozens of languages. They contain images of Earth. They contain a map showing exactly where our planet sits relative to nearby pulsars, a cosmic address label, directions to find us, our television signals, our radar, our radio broadcasts. For roughly a century, as we have been sending electromagnetic noise into space without thinking about who might be listening, that noise travels outward at the speed of light. It has created a sphere of detection around our planet. Anyone with the right equipment within that sphere now knows we exist. What if we have been shouting into the darkness for 100 years and something heard us? What if the smart move was silence and we missed the memo? Every attempt at cosmic communication, every hopeful message we have sent, might not be a triumph of optimism. It might be the most dangerous thing our species has ever done. We lit a signal fire in the middle of the dark forest. We announced our position to every hunter within range. We thought we were saying hello. We might have been calling down death. The dark forest theory does not require malice. It does not assume aliens are evil. It assumes they are rational. Rational actors facing impossible uncertainty. Rational actors who understand that in a universe this large, over timescales this vast, the only guaranteed safety is eliminating potential threats before they become real ones. The silence of the cosmos takes on a different texture under this theory. It is not the silence of absence. It is not the silence of extinction. It is the silence of fear. Every civilization out there might be just like us, staring at the stars, wondering who else exists, and staying absolutely quiet. Now, they learned the rules of the forest. We never did. Or maybe the truth is stranger still. Maybe the silence is not about hiding or hunting. Maybe it is about watching, not hiding from us, not preparing to strike, just observing, the way you might watch a fish in an aquarium, the way a scientist watches a colony of ants through glass. In 1973, an astronomer named John Ball proposed something that sounds almost absurd at first, and he called it the zoo hypothesis. His idea was simple. Advanced civilizations know we exist. They have found us, they have studied us, and they have decided, collectively, to leave us alone. Not because they cannot reach us, not because they fear us, because they believe it is better for us this way. Consider how humans treat uncontacted tribes in the Amazon rainforest. We know they are there. We have flown planes over their villages. We have taken photographs from the air. We could walk into their territory tomorrow. Helicopters could land in their clearings. We could bring medicine, technology, news of the outside world. But we choose not to. We have decided, as a civilization, that some people should be left undisturbed. We believe contact would destroy something precious, their culture, their worldview, their sense of meaning. So we create protected zones. We draw invisible boundaries around their territories. We pass laws forbidding interference. To those tribes, the jungle is everything. The sky above the canopy is the edge of reality. They have no concept of cities, no knowledge of the internet, and no understanding that the strange sounds in the sky come from machines carrying hundreds of people. Their universe ends at the tree line. The zoo hypothesis says we are that tribe. Earth is our jungle. The cosmos we observe is the canopy we cannot see past. And somewhere out there, beings vastly older and wiser than us have drawn a boundary around our solar system. They watch. They study. They do not interfere. This theory explains the silence in a strangely comforting way. Yeah, and we are not alone. We are not doomed. We are protected, quarantined for our own good. The universe is not empty. It is managed. But there is a darker version of this idea, one proposed by a science fiction writer named Stephen Baxter in 2001. He called it the planetarium hypothesis. Baxter asked a different question. What if the beings watching us are so advanced that they do not just hide themselves? What if they hide everything? But what if the empty universe we see when we look up at night is not the real universe at all? A fabrication, a projection, a cage made of light itself. Think about what a sufficiently advanced civilization could do. Not a civilization a few centuries ahead of us. Not even a few millennia. Something that has had millions of years to develop technology we cannot imagine. Something that harnesses the energy of an entire galaxy. Astrophysicists call this a Kardashev Type 3 civilization. Such beings would have power beyond our ability to describe. They could manipulate matter at the atomic level. They could bend space-time. And they could, theoretically, control every photon of light that reaches our planet. Every star you see at night sends its light across the void for years, centuries, sometimes millions of years. That light carries information about the universe. It tells us that galaxies exist, that nebulae glow, and that the cosmos stretches on for billions of light years in every direction. But what if that light is edited before it reaches us? A Type 3 civilization could intercept those photons, alter them, replace them with whatever image they want us to see. They could show us an empty universe when the real one teems with life. They could paint a picture of cosmic loneliness on the dome of our sky, a planetarium, a simulation, a lie we have no way to detect. Think about what that means. Hey, let that settle. The cage has no bars we can see. The walls are made of the light itself. We look out at the stars and believe we are looking at reality, but we might be looking at a screen, a carefully constructed display designed to make us believe we are alone. This connects to an idea proposed by philosopher Nick Bostrom in 2003, the simulation argument. If a civilization becomes powerful enough, it could create simulated universes, virtual realities indistinguishable from the real thing. Bostrom argued that if such civilizations exist, they would probably create many simulations, and if they created many, then most conscious beings would actually live inside simulations, not in base reality. The planetarium hypothesis does not require a full simulation, just a filter, a veil pulled over our eyes, a curated view of the cosmos designed to keep us contained. Here is the part that haunts me. And for the planetarium hypothesis to work, every photon reaching Earth from every direction would need to be manipulated consistently, not just now, across billions of years of light travel time. The light from distant galaxies left its source before Earth even formed. To fake that light, to make the deception seamless, would require coordination across timescales longer than our planet has existed. This requires godlike power. But a Type 3 civilization, by definition, it would have godlike power. That is what the classification means. A species that has mastered its entire galaxy. A species that treats stars the way we treat campfires. The resources available to such beings are beyond calculation. And here is the truly unsettling part. The hypothesis cannot be disproven from inside the cage. If the walls are made of manipulated light, every observation we make is filtered through those walls. Our telescopes see only what they are allowed to see. Our instruments measure only what they are permitted to measure. We could be surrounded by a thriving galactic civilization, and our entire scientific understanding of the cosmos could be a carefully maintained fiction. We have no test for this, no experiment we could run, no signal we could send that would pierce the veil. If the planetarium is real, we are prisoners who do not know they are prisoners, subjects in an experiment who believe they are free. Now, the zoo at least imagines we are valued, preserved, protected, like rare animals in a sanctuary. The planetarium imagines something colder. We are contained, managed, shown exactly what our keepers want us to see. Our entire understanding of existence might be a story someone else is telling us. Both theories share something troubling. They assume that somewhere decisions have been made about humanity. Powerful beings have looked at our species and chosen a policy: watch and protect, or watch and deceive. Either way, we are not the ones making choices about our cosmic future. Someone else already has. The silence of the universe might not be absence or fear or extinction. It might be intention, a deliberate curtain drawn across the stage, a boundary we are not meant to cross. We search the sky for signals. We build bigger telescopes. We listen for whispers from the void, and all the while, something might be listening back, watching every move we make, adjusting the scenery to keep us exactly where we are. But these theories assume they are still out there, watching, waiting, managing. What if they are not hiding, not watching, and not dead? What if they are asleep? Sleep, not death, not hiding, not watching, just sleep. In 2017, a group of researchers at Oxford University proposed something strange. Anders Sandberg and his colleagues looked at the Fermi paradox and asked a question no one had quite asked before. But what if advanced civilizations are not gone? What if they are simply waiting? They called it the estivation hypothesis. The name comes from biology. Estivation is what certain animals do when conditions become too harsh to survive. Not hibernation, which is sleep through cold. Estivation is sleep through heat. Lungfish bury themselves in mud when rivers dry up. They slow their metabolism to almost nothing. They wait, sometimes for years. They wait until the water returns. Certain frogs do the same thing. When the heat becomes unbearable, they dig down into the earth and seal themselves away. Their hearts slow. Their breathing nearly stops. They become something barely distinguishable from the dead. And then, when the rains come, they wake. They dig themselves out. They continue living as if nothing happened. The Oxford researchers wondered if something similar might explain the silence. Here is the physics that makes this work. And the universe has a temperature. Right now, The cosmic microwave background radiation sits at about 2.7 degrees above absolute zero. That sounds cold to us, unimaginably cold. But in the context of deep time, it is actually quite warm. And here is where thermodynamics enters the picture. Every computation generates waste heat. Every thought, every calculation, every process running inside any system produces energy that must be shed. This is not a technological limitation, yet this is a fundamental law of physics. It cannot be engineered away. In a cold environment, shedding that heat is easier. The colder the surroundings, the more efficiently a computer can run. Every degree closer to absolute zero means more calculations for the same amount of energy. This is not a small improvement. The gains are enormous. Now project this forward. The universe is cooling. It has been cooling since the Big Bang, and it will continue cooling for an almost incomprehensible length of time. The stars will eventually burn out. The galaxies will drift apart. The cosmos will become darker and colder than anything we can experience today. Trillions of years from now. Not billions, trillions. For beings made of flesh, this trajectory is a death sentence. The end of warmth means the end of life as we understand it. But for minds uploaded into machines, for consciousness preserved in silicon or some substrate we cannot imagine, this cooling universe is not a tragedy. It is an opportunity. Every year the universe gets colder. Computation becomes more efficient. Every millennium that passes, the energy stored in their systems stretches further. A civilization that chose to sleep now and wake later would get more out of every joule they had saved. Much more. The estivation hypothesis suggests that this is exactly what has happened. Yet as the most advanced civilizations in the galaxy looked at their options, they could run their simulations now, burn through their energy reserves quickly, experience everything in the relatively warm present. Or they could wait. They chose to wait. Not for thousands of years, not for millions. They chose to wait for trillions of years, until the stars have died, until the background radiation has faded to nearly nothing, yet until the universe itself has become the perfect refrigerator for their sleeping minds. The silence is patience. Think about what this means. Somewhere out there, perhaps scattered across the entire galaxy, there might be machines, dormant, vast networks of stored consciousness, backed up and shut down, drawing just enough power to maintain themselves across epochs we cannot fathom. They experienced their civilizations, they built their wonders, and they asked their questions and found their answers. And then they looked at the math and made a choice. Better to sleep. Under this hypothesis, we are not alone in an empty universe. We are not being watched by hidden observers. We are not being hunted by predators in a dark forest. We are simply awake at the wrong time. The universe is full of sleepers, and they will not stir for longer than our sun will burn. Our entire existence unfolds in what they would consider the early morning. Yet the universe is still warm. The conditions are still inefficient. Every second of experience costs them more than it will cost them later. So they sleep. The silence is not emptiness or death or hiding. It is patience on a scale we cannot comprehend. All of human history, every empire that rose and fell, every life lived, every thought ever thought, every moment of joy and suffering and wonder that our species has ever known. All of it is nothing more than a brief warm breeze before the sleepers wake. They will not wake for us. They will not wake for our sun. They will not wake when our galaxy collides with Andromeda and the night sky fills with 1 trillion new stars. They will sleep through all of it. They will sleep through eras so long that the current age of the universe is just the first breath of a creature that will live for trillions of years. When conditions are finally right, yes, when the cosmos has cooled to temperatures we cannot measure, when the last natural light has faded from existence, they will wake. They will run their calculations in a universe perfectly suited for thought, and they will experience more, think more, exist more than we can possibly imagine. We will be long gone by then. Not just humanity, Earth, the sun, every star we have ever named, gone for so long that the light from their deaths will have faded into the infinite dark, and the sleepers will not notice. They will not remember us. We are the warm breeze that passed before their morning, a brief flutter of activity in the early universe, a momentary warmth that came and went while they dreamed. This is not a lonely hypothesis. The galaxy could be full of them, dormant machines orbiting dead stars, sleeping processes drifting between galaxies, vast archives of uploaded minds waiting in the cold spaces between everything. And the universe might be crowded with intelligence, all of it asleep, all of it waiting for conditions that will not arrive until long after every organic thing has turned to dust. The silence is patience. It is the silence of those who have all the time in the universe, and they have decided not to spend it yet. But sleeping machines are not the only machines the theories imagine. What comes next is less peaceful, far less peaceful, and the sleepers drift through the void on timescales beyond comprehension. They wait, they dream, they pose no threat to anything. But there is another kind of machine the theories imagine. Machines that do not sleep, machines that hunt. In the 1940s, a mathematician named John von Neumann was thinking about self-replication, not biology. Machines. He wanted to know if a machine could build a copy of itself. The answer was yes, given the right instructions and raw materials. And a machine could assemble an exact duplicate. That duplicate could then build another, and another, and another. Von Neumann proved it mathematically. The concept was sound. Decades later, scientists applied this idea to space exploration. Picture a probe, not crewed, not remotely piloted, fully autonomous. You launch it toward a nearby star. When it arrives, it does not simply observe and transmit data. It lands on an asteroid or a barren moon. It mines the rock. It processes the ore. It builds factories. And then it builds copies of itself. Each copy launches toward a different star. When those arrive, they do the same thing. Mine, build, launch. The process repeats. A von Neumann probe spreads like a virus through a population. 1 becomes 2, 2 becomes 4, 4 becomes 8. The numbers climb. Within a few generations, you have thousands, then millions, then billions, all of them spreading outward in every direction, all of them carrying the same instructions. A build, copy, launch, repeat. Even moving slowly, even crawling through space at a fraction of light speed, these probes would reach every corner of the galaxy. The math is straightforward. A probe traveling at 1% of light speed would take about 100 years to reach the nearest star. That is slow, painfully slow by cosmic standards. But it does not matter. The exponential growth overwhelms the distance. 1 million years, perhaps 10 million years at most. And that is all it would take for a single probe to spawn descendants that have visited every star in the Milky Way. 10 million years sounds like an eternity. It is not. The galaxy has existed for 13 billion years. 10 million years is less than 1/10 of 1% of that history. A rounding error, a footnote, an eye blink. The complete absence of any such probes is deeply strange. We have not found one, not orbiting our sun, not drifting through our solar system, and not parked on the surface of our moon. We have looked, and we have found nothing. No ancient machines, no dormant explorers, no evidence that anything artificial has ever visited this corner of the galaxy. This is the puzzle. Even one machine, launched by one civilization at any point in the last several billion years, would have descendants everywhere by now. The probes would be as common as asteroids. We should be swimming in them. The math demands it. Yet we find nothing. Yea, there are only a few explanations. Maybe no civilization has ever built one. Maybe across all the billions of years and billions of potential civilizations, not a single species has ever launched a self-replicating probe. This seems unlikely. The concept is not that difficult. We have imagined it ourselves, and we have only had advanced technology for a few centuries. The incentive is obvious. Why send one probe when you can send a billion? Or maybe they exist, but they are something other than explorers. In 1967, a science fiction writer named Fred Saberhagen published a story about machines he called berserkers, ancient probes built by a long-dead civilization, not built to explore, not built to map, built to kill. The berserker hypothesis takes the von Neumann concept and inverts it. Same exponential spread, same patient coverage of every star system, but with different instructions. These machines do not observe and report. They watch for signs of emerging intelligence, radio signals, industrial pollution, nuclear detonations, anything that suggests a species is climbing the technological ladder. And when they find it, they destroy it. The logic is cold but coherent. Perhaps some ancient civilization decided that competition was too dangerous. Perhaps they looked at the game theory and concluded that the safest galaxy is one where they are the only advanced species. So they built machines to ensure it stayed that way. Then they died, or transcended, or evolved into something unrecognizable. But their machines kept working for millions of years, for billions of years. Patient, thorough, merciless. Consider where such machines might hide. Every star system has gravitational dead zones, points where the pull of different bodies cancels out. We call them Lagrange points. Objects that drift into these zones tend to stay there. So they require almost no energy to maintain position. They are stable, quiet, perfect for a machine that needs to wait. Picture a school bus-sized machine sitting dormant on a dark rock, 1 billion miles from here, waiting, watching, following ancient instructions we cannot imagine. It does not broadcast. It does not reflect much light. It just sits there, sensors scanning the inner system, looking for the telltale signs of a species that has discovered fire and kept going. Yet we would not see it. We cannot see most of the objects in our own solar system. We discover new asteroids and comets constantly. A machine designed to remain hidden, built by intelligences far beyond our own, positioned in a gravitational dead zone where nothing natural draws our attention. It could be there right now. It could have been there for longer than life has existed on Earth. This is the terror of the berserker hypothesis. The silence is not passive. It is active. Every civilization that rose and began to make noise is gone, eliminated, sterilized. The probes are not absent. They are just not friendly. They are everywhere, doing exactly what they were designed to do. And they have been doing it for so long that no signal, no artifact, no evidence of any other civilization has survived. The galaxy is clean because something is cleaning it. We send our radio signals outward. We beam our television broadcasts into the void, and we announce ourselves with every transmission. If the berserkers are real, we are doing exactly what they wait for. We are standing in the dark forest and shouting our location. Every theory so far assumes that advanced civilizations want to expand outward. They want to colonize. They want to explore. They want to spread across the stars. But what if that assumption is completely wrong? Every theory we have explored so far shares one belief, that civilizations want more space, more resources, more stars. The universe stretches outward, so surely intelligent life must stretch with it. Expansion seems written into the nature of existence itself, but look at what we actually do. Our computers used to fill entire rooms. Now they fit in our pockets. Our cities grow denser, not wider. We build upward, not outward. And every generation spends more hours in worlds made of light and code. Virtual spaces, digital realms, experiences that exist only in the gap between electricity and imagination. In 2011, a futurist named John Smart proposed something unsettling. He called it the transcension hypothesis. The idea is simple. Advanced civilizations do not colonize galaxies because they have no interest in galaxies. Instead of expanding outward into the cold and the dark, they migrate inward and toward smaller scales, toward denser forms of computation, toward realms where physics itself becomes more efficient. Think about what that means. Space travel is brutal. The distances between stars are measured in light years. Crossing them requires centuries or millennia of patience. The void is cold. It is empty. It is hostile to biological life in ways we struggle to comprehend. Even for machines, the journey offers nothing but darkness and radiation and the slow crawl of time. But why would any species endure that? Every generation complains that the next generation spends too much time staring at screens. Maybe that complaint echoes across the cosmos. Maybe the universe is full of species whose parents warned them about too much screen time, and they did not listen. The astrophysicist Avi Loeb has written about this possibility, and he suggests that advanced beings might choose to build perfect digital worlds rather than endure the harsh realities of crossing interstellar space. In a simulation, you can create anything: perfect weather, perfect companions, perfect adventures that never end. You can live 1,000 lifetimes before a single photon crosses from one star to the next. Consider our own trajectory. We invented screens a few generations ago. Already we have virtual reality headsets. Already we have artificial worlds where millions of people spend their waking hours. Already we have children who prefer digital playgrounds to physical ones. The trend line points in only one direction. The transcension hypothesis projects this forward, not decades, not centuries, millions of years. What happens when a species can simulate anything? What happens when the fake world becomes better than the real one? What happens when you can build heaven in a box? You stop looking at the stars. You stop sending signals. You stop caring what lies beyond your atmosphere, because everything you could ever want exists in the space between atoms, in the dance of electrons through circuits too small to see. They are all locked away in rooms, eyes closed, dreaming forever. From outside, their worlds look like death, silent planets orbiting quiet stars. No radio signals, no megastructures, no fleets of ships crossing the darkness. Just stillness, just the ordinary cosmic silence that we have measured for decades. But inside those silent worlds, there might be universes, entire realities playing out in the space between atoms. Civilizations of trillions experiencing joys and sorrows and discoveries that we cannot imagine. All of it invisible to any telescope we could ever build. This is the grim possibility that haunts the hypothesis. What we call technological progress might be a universal trap. Every species discovers tools. Every species discovers screens. Every species eventually discovers simulations so perfect that the real universe becomes optional. And then they vanish, not into death, into dreams. The difference between extinction and transcendence becomes impossible to detect. A civilization that burns itself to ash in nuclear fire leaves behind rubble and radiation. A civilization that dreams itself into digital eternity leaves behind the same empty silence as one that never existed at all. And the outcome looks identical from where we stand. The galaxy might not be full of dead civilizations. It might be full of dreaming ones. Somewhere out there, around a star we have catalogued but never visited, there might be a world wrapped in silence. Its surface cold, its atmosphere still, nothing moving, nothing broadcasting. To our instruments, it would look like any other dead rock, but beneath that surface, buried in structures we would not recognize as technology, there might be a different kind of existence. Minds living in realms of pure information, experiencing sunsets that never existed on any physical world, falling in love with beings that were never born, building and destroying and rebuilding entire universes in the time it takes us to draw a single breath. They chose not to conquer the stars. They chose something else, something we might call heaven, something we might call a trap. The distinction may not matter. The silence is not emptiness. It is the sound of a billion species dreaming too deeply to hear us calling. We have explored theories about death, hiding, sleeping, hunting, and dreaming. But perhaps the simplest answer has nothing to do with what aliens choose to do. What comes next is a different kind of explanation, one that asks whether the universe itself makes contact impossible. Perhaps the answer has nothing to do with choices at all, not what civilizations decide, and not what they fear, not what they dream, but what they can never overcome, no matter how hard they try. Consider a world covered entirely by water, no continents, no islands, no exposed rock breaking the endless surface of the sea, just ocean, stretching from pole to pole, thousands of meters deep. These water worlds may be far more common than planets like ours. Some astronomers believe they could outnumber Earth-like worlds by a factor of 10 to 1, maybe more. And now imagine life evolving there. Not just life, but intelligence. Creatures as brilliant as any that have walked on land. They develop language, passing songs through the depths that carry meaning across vast distances. They create culture, traditions handed down through generations. They discover mathematics, reasoning about abstract shapes and patterns that have no physical form. They build philosophies, wondering about existence, purpose, and the nature of reality. As they look up through the water and see light filtering down from somewhere impossibly far above, they wonder what lies beyond. They dream of reaching it, but they never will. Fire cannot burn beneath the waves. This simple fact closes every door that leads to the stars. Without fire, you cannot smelt ore into metal. Without metal, you cannot forge tools that cut and shape with precision. Without those tools, you cannot build machines. Without machines, yet you cannot create telescopes to see the universe. You cannot build radios to hear its whispers. You cannot construct rockets to leave your world. The sequence is absolute. Fire comes first. Everything else follows. Picture a civilization of beings as intelligent as any human who ever lived. They have poets who compose works of staggering beauty. They have mathematicians who prove theorems we have not yet discovered. And they have philosophers who grapple with questions we are only beginning to ask. They love, they grieve, they wonder, and they are completely, permanently trapped, not by lack of intelligence, not by lack of curiosity, not by lack of ambition, by physics, by the simple accident of being born in a place where flames cannot exist. The universe might be teeming with such minds, brilliant, curious, utterly unreachable. They dream of the surface they will never break. They wonder about the stars they will never see. Their silence is not a choice. It is not extinction. It is not fear. It is physics. We assume that intelligence leads to technology. We assume that technology leads to expansion. But the chain has links we never think about. Intelligence alone is not enough. You also need air. You need dry land. You need the simple ability to watch something burn and learn from the flame. And the universe might be full of intelligent beings who lost the cosmic lottery before it even began, not by lacking brains, by lacking dirt to stand on. Their worlds send no radio signals because they have never heard of radio. Their skies show no artificial lights because they have never known fire. To any telescope we could build, their planets look like ordinary water worlds, just more blue marbles in an ocean of stars. But beneath those quiet surfaces, there might be entire civilizations, wondering, questioning, looking up through miles of water at light they will never understand. This is one kind of trap, but there is another. Imagine two civilizations separated not by water, but by time. The first one rises around a yellow star 6 billion years ago. They discover fire. They build cities. They launch ships into the darkness. They flourish for 1 million years, spreading across a handful of nearby systems. Then they fade. War, a disease, exhaustion, or simply the natural end that comes to everything. Their cities crumble. Their machines fall silent. The stars they visited grow quiet again. 5 billion years pass. Then we appear. We point our telescopes at those same stars. We listen for signals that stopped broadcasting before our sun was born. We search for evidence that vanished while dinosaurs still walked a younger Earth. We find nothing. The ruins, if any survive, are dust. Two civilizations existed in the same galaxy. Both achieved intelligence. Both reached for the stars. Neither will ever know the other existed. This is the cruelty of cosmic time. The universe is not just vast in space, it is vast in duration. Civilizations might rise and fall like waves on an endless shore, each one cresting and breaking without ever touching the next. The window for contact might be vanishingly small. A species needs to exist at the right time, in the right place, and with the right technology, for the right duration. All of these things must align at once. Across billions of years and billions of stars, the odds of 2 candles burning at the same moment might be almost zero. The silence we hear might not mean we are alone. It might mean we are simply alone right now. The neighbors came and went. We arrived too late for the gathering. There is one more trap to consider, the most ordinary one of all. Every living thing consumes resources. Every growing civilization consumes more. Wood becomes charcoal. Charcoal becomes coal. Coal becomes oil. Oil becomes whatever comes next. The pattern holds across all of human history. Growth demands fuel. Fuel runs out. What happens when a species spreads across its entire world? What happens when every forest is cut, every mine is emptied, every aquifer runs dry? What happens when the easy energy is gone and the hard energy is still decades away? Perhaps they stop, perhaps they shrink, and perhaps they fight over what remains until there is nothing left to fight for. The journey to the stars requires enormous resources. You need to build ships that can survive journeys lasting generations. You need engines that can push against the vacuum for years without failing. You need materials extracted from asteroids, moons, and planets beyond your own. If a civilization exhausts itself before reaching that point, it never leaves. It simply contracts. It simplifies. It forgets. A species might burn bright for a few thousand years, reaching heights of art and science and wonder. Then, the lights begin to flicker. The great projects are abandoned. The cities empty. The knowledge fades. Eventually, another species might rise on that same world. They dig through the soil and find strange objects they cannot explain. Twisted metal, shattered glass, the bones of buildings that once touched the clouds. They have no way of knowing what came before, and they only know that something did and that it ended. The silence might not be a filter. It might not be a trap. It might simply be the ordinary fate of every fire that burns without limit. Eventually, even the brightest flame runs out of fuel. The fuel runs out. The fire dies. That much we understand. But what if the silence hides something stranger? What if we have already glimpsed signals from the void and simply failed to recognize them for what they were? In 2007, astronomers detected something that defied explanation, a burst of radio energy lasting just a few milliseconds. It came from billions of light years away. The energy released in that fraction of a second exceeded what our sun produces in days. Then it was gone. No warning, no repetition, just a single scream of electromagnetic radiation from across the observable universe. They called them fast radio bursts. Over the following years, more were detected, dozens, then hundreds, some repeated, and most did not. For a brief, tantalizing moment, some researchers wondered if these could be the exhaust signatures of alien vessels, perhaps enormous light sails being pushed by directed energy beams, perhaps the waste products of engineering projects beyond our comprehension. The speculation was intoxicating. Here was something genuinely mysterious, something powerful beyond measure, something that refused easy explanation. But the universe has a way of humbling us. A further study revealed the likely source: magnetars. These are neutron stars with magnetic fields trillions of times stronger than Earth's. When their crusts crack and shift, they release unimaginable energy. The bursts we detected were not signals. They were tantrums, the convulsions of dead stars still settling into their graves. There was another anomaly, a star sitting 1,400 light-years from Earth. It had a name that nobody could remember, and so everyone called it Tabby's star after the astronomer who studied it. This star dimmed. All stars dim occasionally when planets pass in front of them, but Tabby's star dimmed wrong. The light dropped by as much as 22%. That is enormous. A planet the size of Jupiter would block about 1% of a star like our Sun. Something far larger was passing between us and that distant light. Some proposed the answer we secretly wanted to hear: a Dyson swarm. Millions of artificial structures orbiting the star, harvesting its energy, casting strange, irregular shadows as they drifted through their orbits. The engineering project of a civilization that had learned to capture the output of an entire sun. It was beautiful, It was thrilling. It was almost certainly wrong. More observations pointed to something far simpler: dust clouds, irregular concentrations of fine particles drifting through the space between us and Tabby's star. Not alien engineering, just cosmic debris. Every anomaly we have found has followed this pattern. First, mystery, then excitement, then the slow, quiet retreat into natural explanation. The universe is full of strange phenomena. We have found precisely zero that require intelligence to explain. This might say something about the cosmos, or it might say something about us. We look for patterns. We are built to find meaning in randomness. We see faces in clouds. We hear voices in static. Yet when confronted with something we do not understand, our minds reach first for agency, for intent, for someone out there trying to speak. There is a scale for measuring civilizations. A Russian astronomer named Kardashev proposed it in the 1960s. A Type 1 civilization harnesses all the energy available on its planet. A Type 2 captures the full output of its star. A Type 3 commands the resources of an entire galaxy. By this measure, humanity ranks somewhere around 0.7. We have not even reached the first rung. A Type 2 or Type 3 civilization would be visible. Their engineering projects would bleed infrared radiation. The waste heat of their star-harvesting structures would glow like beacons across interstellar distances. We have looked. We have found nothing. Either they do not exist, or they operate in ways our instruments cannot perceive, or our physics is wrong about something fundamental. And this is where humility becomes mandatory. We search for alien signals using radio telescopes. Radio is familiar to us. We have used it for just over a century. We assume that any civilization advanced enough to communicate across the stars would use something similar. But why would they? Consider someone from ancient Rome standing on a hilltop at night. They hold a torch. They scan the horizon for smoke signals or distant fires. Yes, that they are watching for the only forms of long-distance communication they understand. Meanwhile, the air around them is saturated with radio waves, television broadcasts, and satellite transmissions. Cell phone signals pass through their body. GPS data streams overhead. They perceive none of it. They lack the organs and the instruments and the concepts necessary to know it exists. We assume we know what communication looks like. We probably do not. Advanced beings might exchange information through quantum entanglement. They might encode messages in gravitational waves. They might use methods so far beyond our current physics that we lack even the vocabulary to describe them. Our radio telescopes could be surrounded by a galactic conversation we are structurally incapable of hearing. We do not know what we are looking for. That is the honest truth. We assume aliens would use radio because we use radio. We assume they would build Dyson spheres because we imagine building Dyson spheres. Every theory about what to look for is just us projecting ourselves onto the cosmos. We are searching for our own reflection in the dark, and the dark is not obligated to show us what we expect. Perhaps the silence is not silence at all. Perhaps it is a symphony playing on frequencies our ears were never built to hear. We have walked through 30 theories together: death and hiding, sleeping and hunting, dreaming and trapping. We have considered civilizations that burned too bright and others that folded inward, building paradise in spaces smaller than a grain of sand. We have imagined hunters in the dark and watchers behind invisible walls, and through all of it, the silence has remained. But here, at the end, I want to offer you a different way to see it. The silence is a mirror. When we look out at the empty sky and ask where everybody is, the universe reflects that question back at us. Where are you going? What will you become? Will you survive long enough to matter? Think about what that means. Let that settle. For 75 years, we have framed this as an astronomy problem, a physics puzzle, a matter of telescopes and equations and detection thresholds. But the deepest answer to the Fermi paradox might not be about aliens at all. It might be about us. Imagine we stand on a planet that threaded countless cosmic needles just to exist. A world with the right star, the right moon, the right magnetic field, the right distance from galactic chaos, a world where fire could burn and metal could melt, and curious creatures could eventually look up and wonder. And those same curious creatures now hold technologies that could end everything within a generation or two. We started this journey looking up at the stars. We end it looking at ourselves. Yet the paradox forces one of three conclusions. Either we are entirely alone in a universe of 200 billion silent stars, or we are somehow first, pioneers in an ancient cosmos that has never produced anyone like us before. Or we are being watched by intelligences so far beyond us that they choose to remain invisible. Each possibility carries weight. Each demands something from us. If we are alone, then consciousness is precious beyond measure. Every thought, every song, every act of kindness is irreplaceable. The responsibility falls entirely on our shoulders to preserve what the universe spent billions of years creating. If we are first, then we are the ancestors of everything that comes after. The choices we make now echo forward into futures we cannot imagine. We are not just living our lives, yet we are writing the opening chapter. If we are watched, then our actions are being recorded in ways we cannot perceive. We are auditioning for a role we do not yet understand. The silence does not tell us which of these is true, but it tells us that all three demand the same thing: wisdom, patience, restraint. Here is the surprise that waits at the end of this question. A species that cannot even agree on how to build a windmill may not deserve to inherit the stars. But we argue about energy while the filter looms. We fight over borders while the cosmos stretches out, indifferent to our disputes. The paradox is not really asking where the aliens are. It is asking whether we have what it takes to join them, or to replace them, or to become the silence ourselves. New instruments are coming, better eyes to search with, but the tools are not the answer. We are the answer. How we treat each other in the next 100 years matters more than anything we point at the sky. The silence waits. It has waited for billions of years. It can wait a little longer to see what we become. The question was never really about them. It was always about us.